This is the second part of your experiment. Okay, so as you can see on the right hand side, to collect accelerations during the experiment, first we're gonna have to use this formula. You know, acceleration is equal to the change of velocity over the time. So that what that means is that in the lab, you're gonna have to time how long does it take for the ball to roll, or the surface sphere or the can to roll until it reaches the bottom of the ramp. So I'm just gonna say 1 and 2, those are the positions, okay? So however, you already know your distance between point A and point B. All you have to do is just collect the time. So if you were able to figure out what the time is, then acceleration is equal to v2 minus v1 over the change of time. And one of the things that we notice is equal to 0 because it is at rest. Let me look. It is at rest. So basically, acceleration is equal to v final divided by time. That's how you would do it in the lab. However, for our theory, we have two different theories, okay? I'm just gonna put it on the side. We're gonna both utilize the second law of motions. But this one is frictionless. Sorry, this one is with friction forced. It's with friction. This one is frictionless surface. And this one we're going to be solving for acceleration, and it might be looking for the coefficient. So this, this types of theory can be asked for two different things. Frictionless surface. Let's go ahead and draw a free body diagram. So we use Newton's law of motion. Now we're going to follow the free body diagram. It's going to be mg psi angle only. That's the only forces acting upon that mass in that direction. So we know that there is an acceleration for sure going down the ramp. So sigma f is equal to mass times acceleration. Mass mg, force is mg psi, is equal to the mass times acceleration. If we solve for acceleration, so we cancel the mass out, so it would be this. So acceleration is equal to the gravity times psi of the angle, which is very easy because there's only one force. However, if there is a friction one, so first we're going to have to utilize the concept of force. How many forces do we have? So I'm referring this one to this body diagram. We have two different forces. So since the object is going down the ramp, so this force has to be greater than the frictional force, equal to mass times acceleration. So I'm repeating the formula. Sum of the forces is equal to the mass times accelerations. So now what it is important if we have to figure out what the frictional force is. So when we refer back to our free body diagram, you only have two different forces right here. And so we're gonna apply the concept of torque and angular momentum, which is equal to torque is equal to the distance, which is radius of that object, times frictional force. It's not this one. Okay, it's that. And the torque is also equal to this, angular momentum. But then you're gonna also have to know that I is different. So in this case, I'm just gonna use an example of solid sphere. But then angular velocity, angular acceleration is equal to translational acceleration divided by radius. That's what you need to know. So you have to apply these two pieces in that one equation. So I'm gonna draw it over here. Torque is equal to inertia times angular acceleration. So torque is also equal to frictional force times radius is equal to I is 2/5 mr squared. Now that is equal to A divided by radius. So now to find frictional force, that's what we're looking for. Solving for frictional force is equal to basically 2/2 mr squared AR squared. Cancel them out. So my frictional force is equal to 2/5 MA. So now what we do is that we're gonna have to replace the frictional force in there. So it will be mg psi minus 2/2 ma is equal to mass times acceleration. So from now I'm just gonna have to combine mass. So it will be mg psi theta is equal to ma plus 2/5 mass times acceleration. So I'm just gonna cancel all the masses. It will be g psi angle is equal to, so that's actually 5/5. So it will be 7/5 accelerations. So acceleration should be equal to 5 times gravity times psi angle divided by 7. So the acceleration in this case is equal to 5/5 gravity times psi. So let me write over here so that you can see better. Acceleration is equal to 5/7 psi. I hope this helped, because for your next, if you were to be using the cylinders, you're gonna have to change I differently. So remember, this is for a solid sphere only.